This question belongs to the topic of power in AC circuits and the subtopic is complex power. The difficulty level in solving this question is medium. The approximate time required to solve this question is around 60 seconds. Given that the input voltage source Vs is equal to 5 cos t and the complex power drawn is P complex is equal to 3 by 2 plus 2J. The value of the resistor R and the inductance L is dash. So the concepts the student should know in order to solve this question is, there are three types of power in AC circuits, that is active power or real power or the true power or the actual power represented by P. Another is volt ampere reactive power or the quadrature power or out of phase power or reactive power, or it is also called as Q power. It is represented by Q and its units are volt ampere reactive. The units of real power is what? The third form of power is apparent power. It is also called as volt ampere power, represented by the symbol S, and its units are V into A, that is voltage into current, that is volt ampere. The relation between these three is S is equal to P plus JQ. The individual formulas are, for apparent power S can be written as S is equal to V into I star. So here in this formula, V is the applied voltage in RMS form and I is the applied current or the current taken from the applied voltage source in RMS form. So P can be written as I RMS whole square into R. Likewise, Q can be written as I RMS whole square into X. Here R is the resistance and X is the reactance of the inductor or capacitor. So I RMS square into X. This into is for the multiplication, this capital X is for the reactance. So this is one relation, this is another set of formulas. There is also another set of formulas. So if you see P is equal to I RMS square into R, which is the formula for real power or active power or true power or actual power. Another formula can also be written as P RMS whole square by R. So just by the application of simple Ohm's law, that is V is equal to I into R, there are two forms of formulas for P. Likewise, for Q also, the formula can be written as, just by application of Ohm's law, I RMS square into X can be written as V RMS square divided by X. So likewise, the formula for S can also be written as, one formula of S is V into I star. So if you see the units also, the units of V is volts and the units of current I is ampere, and hence the unit is volt ampere, that is volt into ampere, voltage into current product. The another form of formula for the apparent power S is V is equal to I RMS square into Z. Z is the total impedance which contains both the resistive and reactance parts. Just by the application of simple Ohm's law, that is V is equal to I into R, this can be further simplified into the form of V RMS square by Z. So if you strictly see these formulas, here the resistance part is anyway a pure resistive value and it does not contain any imaginary terms. But there is chance of imaginary terms in this reactance. So here we have to keep modulus because we have to take only magnitude or modulus value. Q is always a real value. Volt ampere reactive, that is Q can be 23 VAR or 23.5 VAR, some VAR. It cannot be 23.5 J VAR or 21 J VAR. To eliminate that J term, we are using modulus. Likewise, the complex power also we have to use Z star here. Here we should not use modulus of Z, because if you see the formula, S is equal to P plus JQ. P is a real number, Q is a real number, plus J. So the coefficient of J is a real number. So if you see, always S will be a complex number. If Q is equal to 0, then S will be a real number as a special case. If P is equal to 0, then S will be a purely imaginary number as a special case. But in general, S is a complex value, unlike P and Q, which are purely real. So here we have to use, instead of modulus of Z, we have to use Z star. So the formula that will be used in order to solve this question is S is equal to Vrms square by Z star. Why we are using this formula means, in this question applied voltage source Vrms is given, which is 5 cos t, and the complex power S is also given. P complex is equal to modulus of Vrms square by Z star. Here P complex is nothing but S, whose units are volt ampere. We can solve the same problem using S is equal to V into I star formula also. But solving this using this formula will lead you into an equation with two unknowns, namely R and L, and hence you have to substitute each of the option in order to find the correct answer. Moreover, calculator is required in order to solve this question using S is equal to V star formula. So a more simple method in order to solve this question without using calculator is S is equal to Vrms square by Z star. So if you see the applied voltage, Vs is equal to 5 cos t. From this equation we can derive two values. One is omega value. When we compare with cos omega t, we get omega is equal to 1. And another value we are going to get is the amplitude. So this is the maximum amplitude, maximum positive peak or maximum negative peak amplitude, that is V subscript m. Vm is equal to 5. So we know that Vrms is equal to Vm by root 2. RMS value is equal to maximum value divided by root 2, and hence Vrms is equal to Vm by root 2. In the question, Vs is equal to 5 cos t is given. So this 5 corresponds to Vm, not Vrms. So Vrms is equal to Vm by root 2. On substitution of Vm and divided by root 2, we can calculate Vrms value. You substitute Vrms value in this formula and take Z star to the left side and substitute P complex, or this is the S value given, complex power or apparent power. So on calculation we get the Z star value as 3 minus 4i. When you apply conjugate on both sides, we are going to get Z, or the actual impedance value, as 3 plus 4j. For this circuit, if you look from the point of source, the resistance offered by this circuit, in other words the impedance offered by the circuit, because it is a AC source, is given by Z is equal to R plus J omega L. So when we compare R plus J omega L with 3 plus 4j, we are going to get the values of R and L. From the given question, we have calculated that omega is equal to 1. So the values of R is 3 and L is equal to 4. So the correct answer is option D. Thank you.